my favorite developer conference. I love the kind of marrying of all these different topics and like seeing all these folks in person, both people I've met on the internet and real life. It's a super energizing place to be.
Well, this is actually my first time at Universe. It has been awesome. Not only the event and how it looks and feels, but the people and the energy, like everybody's really excited to do really nerdy things. And that's kind of my favorite thing.
The community is really great. There's all different types of people. Everyone obviously really loves the GitHub platform. And we're all here for essentially just making ourselves better and more productive.
I came here, I got open source, and I got a fresh new deck. I'm loving it. It's great. It's fantastic.
The conversation, the number of different topics that you can talk to people about. We literally just had a question and we're talking to some of the GitHub experts about it and solve a problem we've been working on.
Seeing the vibrancy of the community, the colors, even just how things are portrayed and the little gifts that I have a programmable name tag. I love all these quirky little things. It speaks to the community of just how nerdy, but also fun and interactive. And I think it's a really just cool vibe to be around.
I've spoken at many conferences at this point, and most of them are more corporate driven and quite a bit just louder, frankly. But here I've made friends with many people. Everyone feels approachable, and I feel approachable too, and I've really enjoyed that experience so far.
We believe that every developer can be an AI developer with the right tools and training. That's why we've launched GitHub Models on the GitHub Marketplace. A place for you to explore and experiment with a hand-picked collection of top models with entitlements attached to your GitHub account. So let's try out one of the newest models, GPT-4o. We can pass in an initial user prompt to interact with the model, and we can use the playground to adjust the parameters. For example, we can change the system prompt and experiment with the temperature for more or less randomness. Now that we've adjusted the parameters, we can send user prompts to interact with the model, simulating its use for our application. Now GPT-4o looks great, but I want to test how a different and smaller model handles this scenario. So let's switch to Phi3 Mini Instruct and evaluate its response. Looks good. Now we can also navigate to the details page to find out more information about the model through the README, evaluation, and transparency tabs. Now I've made my decision and I want to start using the models with code. By clicking the code button, we get access to some getting started instructions. We can even use a GitHub codespace to create a pre-configured development environment, ready with SDKs and some samples. Now the model API calls use the entitlements that come with my GitHub account. And because the codespace knows who I am, I don't have to add an API key or sign up to any other services to start experimenting in code. Talking about experimenting, let's update the streaming sample to use Phi3 Mini 4K Instruct. We'll also update the prompt and continue with our experiments. Now those entitlements we mentioned earlier follow you wherever you're logged in, including the GitHub CLI. Here, we're calling AI models to create questions for first-year computer science students so they can check their knowledge of Git. But we can even combine other CLI commands with the GitHub CLI. For example, let's summarize the last 10 commits of this repository using Phi3 Mini Instruct. GitHub Models helps minimize the friction as you explore and experiment with AI models. So take your first steps in building AI-powered apps by joining the waitlist for GitHub Models. We can't wait to see what you build next.
Hi everyone. Hi everyone. I'm Kedasha and welcome to Open Source Friday, the show where we talk to maintainers about the apps that they're maintaining. I'm so happy to have you here with me today. And today we have the application MirrorD, and we have Eyal joining us from, I think he said Turkey. I may have gotten that incorrect, but he's here to talk to us all about MirrorD. And welcome to the stage. Hi.
Hi, I am not joining from Turkey.
Right. I was like,
From
it's not Turkey.
Tel Aviv, Israel.
Tel Aviv, right. Tel Aviv, Tel Aviv. Welcome to the show. Welcome to the show. Super happy to have you here today. How are you doing?
I'm doing well. How are you?
Good, good, good. It's Friday. Super happy that to have like a nice restful weekend coming up. Looking forward to that. And welcome to everyone. I do see turkeys in the audience: USA, India, South Africa, London, Ghana, Italy, Rwanda. Welcome, welcome, welcome. So let's get right into the stream, yeah, because these things tend to go really fast as soon as we start talking. So tell me about Eyal. Who are you? What do you do? And where are you joining us from?
Great. Yes. So I'm Eyal. I'm from Tel Aviv, as I said, and I'm a developer. I have been for the last almost 15 years, mostly in early stage startups, mostly in the area of backend. Also done some management roles. Most recently, I am the co-founder of a company called Metal Bear, where we build MirrorD. Yeah, I'm accompanied by my dog here, just off screen, and I am a relatively new parent.
Oh, congratulations.
Bags under the eyes, yeah. So thank you.
Awesome. So tell us about MirrorD. What is it and how did it come to be?
Great. Can I share my screen?
Oh, yeah, certainly.
Great. Awesome. So MirrorD, as I said, is built by our startup Metal Bear. And just a word about Metal Bear, our vision is to build open source dev tools for backend engineers who we feel are sort of an underserved audience in terms of tooling. And MirrorD is our flagship and only project. It is a tool that lets you run a local process in the context, the real-time context of your cloud environment, your Kubernetes cluster. And we'll dive into what that means. But in terms of the problem it solves, and this is a problem I think that any developer who worked on microservices is familiar with, is the problem of testing your microservice in the context of the entire application, right? Because from a certain size of application, you just can't do that locally anymore. And
Right.
then what people usually do is either they have their own personal sort of cloud environment that replicates production, or they have a staging environment that they share with other developers. And in either case, the iteration time to test new code in the cloud is really long, because at a minimum you have to Docker build, you have to deploy, and then it gets to the cloud, and it's not really convenient debugging it. You have to use a remote debugger, or a lot of people just add logs that they print. So it's a really awkward sort of process. If it's a staging environment, it's sort of even worse because it's shared, right? So there's all this red tape, all this process that you have to go through in order to even get your code there. You have to open a pull request. You have to undergo code review. Sometimes you have to wait for other developers to stop using the environment before you can, before it's your turn. So it's a long iteration, and it's the day-to-day work of the developers. So it sort of touches everyone who's in this job. And so MirrorD, by letting you run a local process from your IDE directly in the cloud environment without going through all this process, just really speeds up your iteration. You can directly debug in the cloud from your home, from your machine, from the configuration that you know and are familiar with. So that's a little bit about MirrorD.
Okay. And like what are some of those, you mentioned some, but like what are some of those specific challenges that devs face when working with cloud environments that you specifically aim to solve?
So, okay, there are a couple. On the individual level, as I touched upon, it is the what's called the inner dev loop. So, sort of the feedback cycle that devs have for testing new code. So you write new code, you want to run it, you want to see if it works, you want to then fix it, see if that works, et cetera, et cetera. It's a cyclical process. And it grows more complicated as the application grows more complicated. So that cycle grows in time, and of course that's both time consuming and frustrating because it includes a lot of downtime. So that's one thing that we're aiming to solve with MirrorD. And the second thing is shared environments, right? So a lot of organizations have a staging environment. That's their closest simulation of production that they have, and it's their best testing resource. But it's also a bottleneck because so it's just this one environment. Everyone has to sort of queue up to use it. So that's the other thing.
Nice. So tell me, how did you even come up with the idea to build MirrorD? How did you build it? Was it just you? Is there a team? How long did that process take? And why open source? Lots of questions in one. Sorry.
Yeah, all right. Let me see. Okay, so MirrorD, we started building it about 2.5 years ago. It started with me and my co-founder, Aviram Hassan. And we know each other from our previous job where we worked together at a cloud startup that does fraud prevention for banks, and we experienced this problem together. We experienced the bottleneck that the organization faces with a shared environment. We experienced a very complex architecture that was very hard to test locally. And when we decided to start something together, it was pretty clear that this was the problem that we wanted to tackle. So that was 2.5 years ago. A lot of time has passed since. We are now a team of 10 people, remote and global, spread like really all around the world. So that's us. We have MirrorD, the open source project that's at the core of it all. We also have a paid offering on top of it. So that's sort of a little background about about the team. Cool. And you asked, why open source? So I mean, it'll become a little clearer when we dive into the technical bit. But I mean, first of all, we want developers to use it, and they often like to know what's under the hood. We think it helps, adoption. It helps just getting people to use it if they can, but both from a curiosity and from a security perspective, know what it actually does. And also, MirrorD has some really cool tech underneath, and we just found it very useful to be able to share that. We have a blog where we share, our little war stories, and that's how a lot of our user base initially found MirrorD. So those are some of the reasons.
Sweet. So let's get into the technical bits. Can you show us how it works? How would we integrate it into our projects? What does that kind of look like?
Yeah, absolutely. So just a quick overview of how MirrorD works. So when I use MirrorD, I give it two sort of arguments. I tell them this is the local process that I want to run, and I tell them this is the pod in the Kubernetes cluster that I want to, we call it target, whose context I want my local process to experience. And it does it with two components, one running locally, that's called the MirrorD layer or client, and a remote component called the MirrorD agent. Now, when I start MirrorD, and we have either a CLI tool or a VS Code or IntelliJ plugin, we're going to see that in a little bit. When I start it, the first thing it does, MirrorD injects itself into the local process as a library, and it starts the Mirror agent on the cloud. Now, for this example, let's assume that I am building a microservice called the user service. I'm currently working on version 1.1, and I have version 1.0, the stable version, running in the cloud. So I started the Mirror agent. It is started on the same node as the pod that I chose to target, in our case, user service version 1.0. This is so it has access to all of its network traffic, its file system, environment variables, etc. And this is where the cool part happens. So the client, what it does, it overrides all of the local processes, input and output syscalls. And it does it without you having to change any code in your local process. It overrides all the calls to environment variables, DNS, incoming, outgoing traffic, file access, and basically, all of the sensory information that your process has, and it proxies them to the cloud instead. And then in the cloud, the agent mediates this logic. It executes the syscall the same as it would have been executed locally, but on the cloud. So if you take a simple example, let's say your process tries to read a file, the Mirror client would then intercept that call and send it to the cloud, the agent instead. The agent would read it from the pod and return the value to the client. So your local process tried to read a file. It doesn't know that it's actually reading a file from the remote pod. And we do that same thing for traffic, for environment variables, etc. The result being that your local process is still running locally, but it thinks it's running in the cloud. And what we achieve is just giving you the ability to test in cloud conditions without deployment, and completely locally. So you can make quick changes, test them out. You can debug in your IDE. That's how we speed up the loop. And additionally, the stable version, version 1.0, is still running in the cloud. It's still answering requests. So I'm not disrupting the remote environment, meaning a lot of people can use Mirror on that same environment, even on the same service, without interrupting each other. So the bottleneck is now eliminated. So that's a little bit about technically how Mirror works. We have a demo.
Yeah, that was so much information.
Okay, so I guess we'll move on to the demo. And for the demo, I set up a test cluster, which I have borrowed from the Istio documentation. It's an sample application that they provide called the Book Info. It's just a couple of microservices in different languages. And just the way it looks, it exposes an endpoint to the internet in our case. So this is it. And let me go to VS Code, where the interesting stuff happens. Let's hide this. Oops. Great. So I already have the Mirror plugin installed, but in case I didn't, it's very easy to install. You don't need anything, just Mirror in the marketplace.
Oh, it's an extension.
It is, yeah. It comes as an extension for VS Code or for IntelliJ or as a CLI tool.
Nice.
So you just download it and you're good to go. I'll also say, I mentioned we have a paid product, but everything we're going to see here is in the open source and completely free. Great. So as we said, for this example, I'm a developer working on one of the microservices. And that, in our case, it's going to be the product page. It's a Python microservice. And I can run it locally. And when I install Mirror, I get this little button, which I can click. And it doesn't really do anything at this point. It just enables Mirror. And what it means is that the next time I run my process within the IDE, it's going to run with Mirror injected inside it. So let's just do that. Great. So now what we're seeing is that Mirror D is offering me all of the pods in the cluster, letting me choose which pod I want to target. So because I'm working on the product page, I'm going to target the product page pod. Let's give it just a second. All right, so we're up and running. So what's happening now is that the product page service is running locally on my machine, but it has Mirror D injected inside of it and overriding all of its. Yeah. So, go ahead.
How does it know what to do? Like, is it looking at a Docker file? Like, is it going, like, how does it know to run it? So after you install the extension,
Yeah.
then you click the button to turn it on, and then it just works.
Okay. First of all, yes. But
What?
let me explain how this happens in a little bit more detail. So when I have Mirror D enabled, we listen in VS Code on when you start debugging. Okay, and when you start debugging your process, what we do is inject Mirror D into the binary that VS Code runs. And this is something that Linux and macOS let you do using an environment variable. So you can give an environment variable with a library, and the library will be injected to the process. So that's how we sort of get started.
Wow.
Yeah.
That is very seamless. I'm impressed with how that's operating under the hood.
Well, that's fun to hear. So we're up and running now. And I guess the best demonstration we can do is, let's just put a breakpoint on one of our functions. For example, the function that is called when there's a call made to the website. And this is arc. This is on the internet, right? So it's a public IP. It's not a local host or anything. So I'm just going to hit refresh, and my breakpoint has been hit in my local process. So Mirror D the Mirror D agent has intercepted the remote traffic and sent it down to my local process. And now I already get some value because I can debug real sort of requests from, for example, my staging environment locally. So that's already nice. We can dive into one of the internal functions. For example, get product reviews, right? So as we said, the product page makes a call to other microservices. So it tries to hit this URL. Now, if I go to my terminal, and this is my local terminal, and if I curl this URL, I'm going to get, I don't have that host defined, and I don't know what reviews is. But this request works, because what happens is that Mirror D intercepts the outgoing network call, and it executes it from the context of the remote pod instead. So that includes the remote DNS and everything, So if, for example, only the product page is allowed to access the reviews microservice, that's going to work because the request is outgoing from the network namespace of the product page. So that's another little demonstration. And as I said, it works for file access, environment variables, etc. And another thing that's interesting about Mirror D is that it's very configurable. So at the moment, I have no configuration. It's just the default mode for Mirror D. But if I go here, I get this menu, and I could go to settings, and it creates Mirror D JSON with some default configuration. Now, let's talk about incoming traffic. By default, incoming traffic is mirrored, meaning we send a copy down to the local service, but the service that answers the request is the remote process. But what if we want our our service to be the one that answers the request. So we can change this to steal. And let's make a small change to our code. All right, so comedy of errors is one of William Shakespeare. So this is going to be Kedasha. Here it plays. Let's run it again with the new configuration. Select the product page. Oops. Oh, there we go. And now we can see that it's my local service answering the request.
Wow.
So that's another mode of operation for MirrorD, and it's very configurable. So this implementation, by controlling all of the syscalls to a very granular level, we can control exactly what happens remotely and what happens locally. So if, for example, you want a request to a certain host name to hit your local machine, you can do that.
I was just going to ask you that. Yeah.
Yeah, if you want certain files to be read from your local machine, you can do that. If you want environment variables, some from here and some from the remote, that's also possible. Yeah, so that's a short demo of how it works.
That's crazy. Okay, so if you wanted to connect it to a particular pod, how would you do that? I guess in the JSON file.
Well, that's possible, but I get the drop-down menu when I first start execution. So it asks me what pod do you want to target. I'll also mention that you don't have to select a pod. For example, what if I just want to run Postman in the context of the cluster? What if I just want to run like Postgres admin? I don't have like a target pod. I can do that as well. Yeah.
This definitely makes debugging like your services so much more seamless, because it's literally just showing you exactly what the prod environment is doing. Like you don't even have to go through this. My mind is blown. I'm sorry. That's why I'm a little taken aback, because the developer experience is so good, because it seemingly just works. Can you tell me more about the you mentioned a MirrorD agent? How is that working? Because is that what's doing most of the heavy lifting?
I guess 50%, right? So I think we'll be able to see it. Yeah, you see, so that's the MirrorD agent for my current session. So we said, we have the client that overrides local syscalls and sends them to the agent. The agent runs as a pod on the same node as the pod that I'm targeting, right? And this is what lets me or lets the agent execute all of this very sort of low-level logic. If for example, it tries to read a file, it's on the same node, we just access the file system, send out a network request, it's in the same network namespace. And I'll add to this that because all of MirrorD's logic, both in the client and in the cluster, is very low level, very sort of close to the process or the pod, then it doesn't really care what's running around it, right? So if we're talking about the cluster, right now I have a cluster running Istio. MirrorD is not affected by it. It is not affected by the size of the cluster. You could have thousands of pod running, and it's not, it scales seamlessly because it's running just around the single pod that you're targeting.
Interesting.
Yeah, and it's the same thing locally, because MirrorD doesn't care, for example, what language your process is written in. For the client, it's just it's working with the syscalls. So as long as
So what about how does it handle like if multiple developers are running Mirity agents against the same like cluster?
That is a very good question. So no, it's called Open Source Friday, right? This is a use case that we handle in our paid version. With the open source, there's going to be some undefined behavior.
Yeah.
But yeah, what our paid version adds is something called an operator, a Mirity operator, which orchestrates between different instances of Mirity running on the cluster. Now, additionally, in the case of, for example, incoming traffic, we have something called HTTP filters, which lets you only receive traffic that matches a certain header. So
Yeah.
multiple devs can run against the same service and receive their own traffic without interrupting the other devs.
Wow, that is so impressive. Like my brain is just like doing a lot of noodling because I'm just like, how is this like even though you've said it multiple times, I'm just like, how is this working? Like how is it doing what it's doing? But it's it's doing what it's doing and it's doing it very well, very efficiently. So talk to me about the life cycle of the agent. So we know how it's initiated, but like does it shut itself down or like how did you stop the process? How does it shut down?
That's a good question. So it's actually a job, Kubernetes job, where we set, there's a parameter that controls auto cleanup. And so after your session ends with the agent, then the job just cleans itself up. So I hope.
What?
Yeah, it's completely transient.
Wow.
So still here, completed. All right, there we go. It's gone.
Yeah.
Yeah.
So it's almost like when you start your Flask server and then you stop it and it's gone.
Yeah, because we don't want to, pollute
Right.
your cluster with a bunch of agents. So
Yeah. That's pretty cool. I'm not seeing much questions from the audience, so I'm just gonna keep asking my questions. Let's talk about a little bit about security with that Mirity agent, right? So, like, what security measures are in place to ensure that the agent doesn't compromise, like anything in the environment when running
that's
locally
a good,
and such?
Yeah, that's a good question. So the default mode of execution. First of all, let's discuss what permissions the agent even needs. Yeah. So the agent needs some extra capabilities in order to be able to sniff incoming traffic, read files, etc. These are listed in our documentation. I don't remember the exact ones. And the default mode of operation is very read-only. But in the end, Mirity is intended to be run on staging clusters or not production for that matter, because it can and should affect the environment. If you want to test mutating logic, then the agent's gonna have to write, for example, to a database to send outgoing requests, etc. And yeah, I'll just add, of course, that in the paid version, there's a bunch of security features added that lets you control it more strictly.
Okay, cool. And so is the VS Code extension the only way that we can interface or use Mirity? There's nothing to install, nothing to do. We just use the extension from our preferred IDE and go our way.
Exactly. Yeah, and of course, there's also a CLI tool. So if you don't like VS Code or IntelliJ, then you also have that option.
Cool. And we have a very interesting question from Maxwell. So I would like to know how it would handle different versions of Linux or different operating systems. Like, would it work if you had devs using WSL and some devs using macOS and some devs using Ubuntu? That's a very good question.
Yeah, it's a great question. So, I mean, let me start by saying it doesn't like the blend doesn't matter. You know, you can have some devs using Mac, some using Linux, etc. Because each Mirdi instance is standalone and unaware of the other devs. In terms of support, we support Mac, we support Linux, and we support WSL because Mirdi relies on libc. Then we don't support native Windows execution at the moment. Yeah, hopefully that answers it.
Cool. Any more questions from anyone? Isaac says, I noticed the pricing page on mirad.dev compares team and enterprise features, but it doesn't include the open source version. How can we compare the features of the open source versus teams? And like, what are the features of the open source offering? Great question.
Yeah, really good question. So the main thing that the paid version adds, the main differentiator, is, as I mentioned before, a component called the Mirdi operator. The operator is a deployment that runs persistently in your cluster. And what it offers is an orchestration component between different instances of Mirdi. On a bit of a higher level, what it does is make Mirdi better suited for organizations and not just individual small teams, etc. So it adds collaboration features, security features, and management and governance. The open source is standalone, right? So it needs access to your Kube API. It uses that to create its own agent. It needs permissions to do that. So that's the technical difference. Yeah, that's the main differentiator.
Cool beans. And so, like, what has the response been like from the open source community over the past, you said, like 2 years? Are they receptive towards the product? Are they what are they like most excited about when it comes to Mirdi?
I mean, first of all, it's been the community has been very helpful in shaping Mirdi. It was actually originally intended to be run on production, but a lot of DevOps engineers shouted at us, so we changed it to be meant for staging. It's been well received. I think at the beginning there's been a lot of skepticism by us as well. When we set out on this journey, we didn't really know where we're going to end up. It's a very sort of complex product technically. And it's always sort of surprising that it works, but it does. So skepticism at first, and I think excitement as the product matured. And there are a lot of users. So
So me having the face like, huh? What is it? What? Is a normal reaction.
We love to see it. Yeah.
I see another question, but I wanted to ask another question. So, like, tell me about how Mirodi is built. Like, right? Like, what tech and tools are you using to create this beautiful system that just works?
Rust. In a word.
Rust.
Yes. It's most of it is Rust. The agent, the client. There's unfortunately some assembly in there. I won't go into that. And for the extensions, of course, TypeScript for VS Code and Kotlin for IntelliJ. That's what we're using.
Yeah, I'm looking at the GitHub repo right now, and it says it's like 97.5% Rust. So that is pretty cool. So one more question. So has it been tested in cloud dev environments like Gitpod or even GitHub Codespaces? That's a really good question. Are we able to use it with those type of cloud environments?
First of all, yes, you should be able to use. I'm not sure if we have tested it on GitHub or Gitpod or Codespaces specifically. It does work on dev containers, for example. So you should be able to use it there. Of course, if you can't, find that you can't, then tell us on GitHub or on our Discord server, and we'll get it done.
Cool beans. And can we try, I'm seeing a question here on LinkedIn. Can we try perf testing or load tests from local with Mirrord, and does it scale?
So that's a really good question.
Yeah, performance testing, perf.
Yeah. So, you know, the one sort of gap of Mirrord, like how is it different from deploying it to the cloud, is you're running on different hardware, and you've added this network step. Whoops. So we don't, the one thing we don't recommend it for is load testing or perf testing, because it won't be like you won't really be able to trust the result. It won't simulate the real world to, you know, as much as you might want it to.
Cool. And okay. I'm blown away by this project. So much so. I mean, it's because I saw you installed the extension, and then you clicked like a breaking point, and then, you know, it ran, and then it, you know, it simulated the environment, and I'm just like, what? There's nothing else to do, and then you're like, oh yeah, we can configure things, and it's just a JSON file, and it's just like, what? It's just like, how?
And this has been, you know, sort of a guiding principle, because devs hate that, you know, all the messing around you have to do to get stuff working. And we work really hard to provide that experience, and yeah, so you don't have to sign up to anything either. It's all on-prem, even the, you know, paid version. We just want to, you know, provide the value without any of the hassle. So
yeah, because sometimes it can be such a hassle, and just like, forget it. I'm not gonna even use it. I'm gonna just implement my own solution, because this is too arduous. That's very, so like, how did you come up with that seamless developer experience? I'm very curious about that, because it's so seamless. Where did that come from?
I wish I could take credit, you know, but it was my co-founder's idea, Aviram Hassan. I think that, you know, the thought behind it was just trying to break the problem down. Like, I want to test in a cloud context, but I want to keep the local experience. So how do I do that? You know, and what does testing in cloud context mean? Like, what do I want the process to sort of experience for me to be happy with the results of the test? And that's sort of the thought process, I think, that led to, okay, so let's just, you know, proxy all of the input and output. We don't need the process actually running in the cloud.
Nice. Yeah. So it's a matter of breaking down the, I guess, the developer journey into like bits and pieces and chunks to get like the best developer experience possible. That's really good. That's really good. And what are you looking for from the open source community? Unless, is there anything else you want to share? What are you looking for from the open source community? How can they support you?
Yeah, absolutely. First of all, we're always looking for contributors. We have issues marked as you know, good, best new or good new issues on our GitHub. It's not super easy to get into the stuff. I mean, there's some very sort of arcane technology being run there. But if you find it interesting, go ahead, and we'll be more than happy to help. I'll mention again that we have a Discord server where we're always available and happy to support contributors or users. And also, I mean, everything is open source or in the ecosystem. So the extensions as well. Our website is open source, so documentation can be contributed. So I guess that's the first thing. And of course, feedback. You know, try it out. If it helps you, tell us. If it doesn't help you, let's even like tell us more. I guess these are the main things.
Nice. Well, thank you so much for like coming on today and talking to us about Mira D. I'm super impressed with the project, and I'll definitely be like sharing it around with. So like, if anyone ever asks, oh, is there an open source project where I can like test my cloud environments locally? I'm just like, yes. Go to Mira D, and it just works out of the box in your preferred IDE. Like, it's so impressive. Thank you everyone for joining. And I did see someone found an answer to Isaac's question in regards to like comparing Teams version to the open source version. You can check out their documentation. It's very good, very approachable. And if you have questions, open up an issue in their repository on GitHub, and they'll be sure to help you out. Thank you so much for joining us today, everyone. This has been Mira D on Open Source Friday with Eyal and myself, Kedasha. Until next time, we will see you next week. Bye.